Example, drawing 4 marbles from a box with replacement. A box contains 3 red marbles and 7 blue marbles. Four marbles are drawn with replacement. Okay, so what does that mean with replacement? It means that we take the marble out and then you look at the color and then you put it back in. So the result is the box doesn't change each time you draw a marble because you're putting the marble back in the box. You're supposed to be shaking them all up. And when we say drawing them, we're doing it randomly. What is the probability that the 4 marbles drawn are blue, red, red, red in that order? Okay, so we're looking at probability of blue, red, red, red. Now, I don't even know whether I should put the comma there. Sometimes I do, sometimes not. But, all right, so what happens is that you have 3 reds and 7 blues. So what happens is you look at the first one, that you get a blue, and there's 7 out of 10 blues. Then what you do is you put the marble back in. And then you're saying, well, out of those 70% of the people, or whatever, 70% of the time you get a blue, what percent will get a red? Well, the box looks the same, and so it's 3 out of 10. So 3/10 of the 7/10 will get a blue and then a red. And the box doesn't change. Then you put the red back in, and so to get another red, it's 3 out of 10. And to get another red, you get 3 out of 10. So this starts getting to be a large number. 10 times 10 times 10 is 10 to the 4th, and then 7 times 3 to the 3rd. I'm going to leave it like that. Well, I don't have to, but it's not that big of a deal. 7 times 27 over... so, of course, I don't have a calculator now over the side here, but maybe since I already started doing this. So there's 4 zeros there, and then, of course, then I'll have trouble maybe doing, this is 189 if I write this as a decimal. There's 4 loops here from the decimal place. That corresponds to 4 zeros. Oops. Okay. All right. So these are independent events. Because what you get on the first does not affect what you get on the second. So look, when you have 4 things happening, you multiply the probability of each of those things happening. And the probability of red is not affected by whether you got a blue or red the first time around because we're replacing the box. So you just multiply those probabilities out, and they tend to start getting to be large numbers. Here I only did 4 drawings, but you can do more. And so let's do part B. Part B is what is the probability that the 4 marbles drawn are red, red, blue, blue, in that order. So you're looking at probability red, red, blue, blue. The box is our same box. Each time you take the marble out, you look at the number and then you write that number, or not the number, the color, and then you look at the color, then you put it back in there. So you multiply the probability of the red. That's the first time. What's the probability you get a red the first time? 3 out of 10, because there's 3 reds out of 10. And then you look at the second time. Out of the 3/10, another 3/10 on the long run will get a red. You just multiply this together, because when you draw from the box, you're putting it back in. It's with replacement. And because it's with replacement, the events are independent. And then we're going to multiply probability blue. Well, we have 7 out of 10 are blue. Then probability blue again. That's 7 out of 10. So this makes 9 times 49 over 1 with 4 zeros. And 9 times 49 is, well, it's something you can just look in your calculator, but 9 times 4 is 36, plus 4 is 441. So, you know, I do stuff like that, then maybe I did it wrong, but that's what you get there. Okay.